guys? All right. Yeah. Okay. So we have completed first day and second day's topics. Today, third day's path analysis. Partially, I did using the latent model. Today, we're gonna use the imputed model. Okay. So how to develop the imputed model? We'll do that first. Okay. So I'll go to my data set. Okay. And so please open the blank Amos sheet. Please open blank Amos sheet. Okay. All of you, please open blank Amos sheet. Or open the Amos. Okay. It's like I'm opening mine. Yeah. Okay. This is not going. I'm not going to use this. Okay. So I'm going to delete this actually. Not delete. I'm just going to say new. So you got this blank sheet. Okay. You can also, if you want landscape, you can also do landscape. I'll change this to landscape A4. Okay. Now here I'm going to draw the imputed model. I'm going to draw my imputed model here. So how I'm going to do it? First, we need to get the data. Okay. So get the data using this. Okay. I can go there. I'm going to use the same clean data set. You can use text, okay, or you can use Excel. Let me use Excel. I have already used the text yesterday, so because I will use different types of data files, so we'll have more experience about that. So I can use the latest one, that is .xlsx, or these are the older versions. So anything beyond 2007. The extension is .xlsx. Okay, so this clean data set, open. Okay, I got this data here. Click OK. Now I'm going to draw the imputed model. So the first thing I'm supposed to do, I'm supposed to open the list of variables. So please click this list. Okay, from there. So this is actually not going to help me because I need the scored one. Okay, the one I had. So imputed data set or clean data set underscore C. Yesterday I imputed the data. It's called data imputation. So if you impute the data, you get the average score. So we need the average score of the variable in order to run the imputed model. See, latent model we can run as it is. Imputed model, either you take the average of it, or you take the sum of it. Okay, or you take the weighted average or the average created by the software. Okay, so I'm going to use the average that is created by the software, these average scores. Okay, then only I can create the imputed model. Okay, so this data is actually in the SPSS. So I would suggest you import the data from the SPSS, since this file you may not have. Okay, and I'm going to actually import, or if you want to import the data from Excel, so first you export it in the Excel, save it, and then you import it from the Excel. I'm going to do that actually. Export database Excel. You can export in CSV also, CSV data. Okay. Text is also there. I think text file is also there. So I'm going to export in XLX and save it. Same name, I'm going to keep it. And if I want to export in CSV, that is also possible. Okay, I'm going to do that. I'll export multiple ways, or you can save as. Both will give you the same results. Okay, you can save as, like these options. You can get save as text, dat.dat. Okay, at tab limited. Okay, or you can also either you can export CSV data fixed text, that is dat file. Okay, this way also you can export ESI C1 that same date that we're getting C2. Okay, just a moment. Which that I'm getting here? C2. Text that C2. Yeah, same. I'm getting same here also. Same one. Okay, either you can do it here, or if you get confused, just go here, export Here you have Stata is also another software. SAS is also another software, very popular in the US, but you need to give commands. Like you have to give, it's syntax based. Okay, now I don't know whether they have started this one. CSV is this is comma delimited. CSV also limited. So I'll go that. Okay. That's like a code based code. You have to write the codes. Not difficult. Okay. All right. So I'm gonna do with the text, fixed text. Okay. I'm gonna save in the same name, save. Okay. I saved it. Okay. So if I go here, I have saved a couple of data. Already I had this data set. Okay, let me go back and forth. I saved it here, no, not here. Why I saved it? Why? Oh, yeah, this is that one. Okay. If I want to import from here, just a moment, I'll get out and I'll just stop sharing. Again, I'll share the screen. Yeah, I'm sharing again. Don't worry, we'll go there. Okay. So it's open, not open. All right. Let me import the screen. Yeah, let me import the data. File name, make all files. I'll create it as text. Okay. Anyway, I imported this one also. Yeah, I got this. So I'm going to import clean underscore dataset dot c. Okay. Okay here. Let me export also CSV file. I'll come back here. CSV file. Export CSV data. So export just a minute. Export. All right, done. Let's go to Amos. Now I want to draw. So I got the data. Just click the variable list. Yeah, I got this. Okay, so either you can like draw this thing here. Okay, and bring the name like this one. I'm gonna call playful. Drag and drop. This is also okay. Or what you can do directly, you can drag from here. Okay, drag from here like decision quality like that. Also you can drag. Okay, decision in compute like that. Also you can drag. Then we have info acquisition. Okay, point, click, and drag. Info acquisition. Then we have compute useful. Anxiety I don't want to bring because anxiety is a moderating variable. So right now I want to bring it. Now we can resize this. How to resize? Go to plugins, resize observed variables. Okay, we resized it. Using this red color truck, we can, I think useful is on the top. We can actually set the model like this. We're going to make the similar model, this model, the same model we're going to build there. We're going to create this model. Okay. So right now we are creating only this model. We are ignoring the other things. We're just creating this model. Okay. And also we're going to include the control variables. What is a control variable? Control variable is essentially an independent variable without a hypothesis. Okay, it doesn't have hypothesis. Why do you use control variable? We use control variable because we want to control the confounding effects. What does it mean? Okay, suppose you are doing a study. Ignore this example, this model. Just to give some idea about control variables. Suppose you are running a study where you are saying that screen time or TV time, screen time or computer time leads to obesity. if this is your study, okay, it's to obesity. And you you prove this study that screen time makes people to gain weight, they become obese, and you prove this and you ignore other factors. So ultimately you'll conclude that just because of screen time people are becoming obese. Would it make sense? Does it make sense? Don't you think there are other factors are also responsible for obesity, like food habit, the diet, the culture, the genetic, okay, the lifestyle, your sleep deprivation, stress? There can be a lot of number of factors. Okay, the place you live, the kind of climate you have. So if you bring all the important factors here, at least few of them, and then when you bring them inside as controlling them, and then you run this test, and if this becomes significant, then we can tell that screen time do have influence on the obesity. Just ignoring them, and even they are very important factors, and just proving this doesn't make any sense. So similarly here actually these are basically demographic variables. We also use non-demographic variables. So age and frequency, the frequency of use, the excel, or the age of these people, if you control them, you can get better quality. It is good to use control. Okay, always need not be too many, but one or two, it is good to have. Okay, and you'll also learn why it is technically also important while running the analysis. Okay, so we have two control variables here, age and frequency. So I'm going to bring them also. Let me connect it first. Okay. All right, so is the model unchecked, and now we can add error terms here, 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 here. You can rotate like error terms because these are the endogenous variables. So you have to give error terms. This is there. Here is not required because it is exogenous variable, like independent variable. Okay, so we have to give the names for the error terms. So name unobserved variables. We have named them. Okay, and now we can run it. Okay, let's run without the control. Then I'll add control later. Okay, so go to analysis properties, go to output, standardized estimates, then squared multiple correlations, close it, go to plugins, open standardized RMR. I think I have to save it. I haven't saved, so I'll save it. Save as my first structural imputed model. All right. Okay, now we are ready to run. I think so. Okay, just open this box, standardized RMR. Let's run it. Okay. Run. Standardized RMR is terrible. It is greater than 0.08. It's terrible, not good score. I'll go to model fit. This is also really bad. It's supposed to be less than 5. It's way too high, 121. This is also really bad. It's supposed to be greater than 0.9, but it's less than 0.9. What about the RMSA? RMSA is too bad. It's really terrible. It's like 0.568. It's supposed to be less than 0.05, 0.08. So we're all bad, Results are okay. Results are fine, but we have terrible model. So what to do? We used modification indices last time. So this time also we're going to use modification indices. Modification indices is kind of a tool that helps you to figure out where your model stands and kind of improvement you can do in the model. Okay, by connecting the lines, arrows, covariances like that. Okay, so I'm going to keep 4 because our model is smaller here. So the default 4 I'm going to keep. I'm going to run it again. Okay, so I ran. All right, this time what suggestions it provides? It tells that I should connect these lines so this percentage would improve. Okay, this percentage of the estimates would improve, or this percentage of the overall model improve. So it is strongly suggesting me to connect the info acquisition to decision quality. I think this is the strong. So I'm going to do one by one. I would not connect all, but I would connect one and I would run again and I would see. Okay, I would not connect all of them. So I'm going to connect only info acquisition to decision quality. The third one. Okay, it gives a lot of value. So go to here. This is what basically it says. Okay, and we'll see how much model we improve. Okay, then you run it. Go to text output. See the first you see the model fit. Drastically improved. Not great, but from 120 something it became 14. So that is way better, isn't it? CFI is greater than 0.9. RMSE is 1.89. We do still have problems. Okay. So again, we'll run it. Again, we'll run. So now this time it's telling us that we should connect. If I connect compute to useful, this one, or useful to compute, this much percentage. Useful compute. Okay. So let's connect this by the line useful compute. Okay, connect it. Okay. Run. Text. Model fit. Yes. This model has become saturated because the degrees of freedom is 0. Okay. This is the problem of imputed model. So when you run the imputed model, the degrees of freedom, you don't have much. So it doesn't, the breathe, there is no air for breathing. Okay. So this more the degrees of freedom, better for the model. So because we connected all the lines, so our degrees of freedom became 0 and our model became saturated and we're not able to see the values. Other things are fine, but the model fit, everything says, 100%, 100% like that. Okay, RMC is also bad. So what to be done? We want to improve the model at the same time. So something helps here is called the that thing, the control variables, age and frequency. I think we have used. So you bring the control variables here, age and frequency, maybe this one. Yeah. Okay. Close it. Resize all the variables. Okay. Now connect them. There are two opinions. Actually, it says either you connect them or dependent variables or connect them with all. Okay. So I'm going to connect with the only one now, and I'll go with the modification. This is what suggestions it provides, and based accordingly, I'll connect more and more. Okay. So I'm just connecting with the decision quality. Since they are the independent variables, like they are like a control variable, so we are supposed to co-vary. If you don't co-vary, also you can run the analysis. Supposed to co-vary and we run. If you don't co-vary, also you can run. Let me run without covariance, and then I'll co-vary. When you run, no, it will say proceed with the analysis. This is not connected. So I can run without covariance. So now I'll have more degrees of freedom. Okay. Model fit is improved. Great, great, great. Lot improvements you can notice. And if you look at the degrees of freedom, we have like 9. We have not connected a lot of things. Okay. So we have 9. So it's say useful and frequency must be connected. So this much we can improve. So let's connect useful and frequency. Okay, I connected this. All right. Still, I'm not co-varying. I'll do it later. Okay. I ran model fit this time. Closer less than 5. It's okay. Acceptable. Greater than 0.9. RMSCA is still not good. It's supposed to be less than 0.0, less than 0.08. Another more connection they are saying, if I connect frequency, a co-vary, playful and frequency. So, okay, I'll co-vary that because, all right, only this it is telling. Okay. What model did you get now? Yeah, we got great model, guys. 1.103, 0.99. RMSE also less than 0.08. Super model. And if I look at standardized RMR, is also 0.02. So we got great model fit. Okay. And if you look at the other things, this is where the results are. Okay. Results means This is your hypothesis results. You have to ignore the line, these lines, because they are actually control variables. So we are not testing those hypotheses. So we have to ignore them. This line also have to ignore. This also you're not supposed to keep there. Any other? I think all other things we can use. So only this hypothesis is not influencing. Other than that, all the hypotheses are significant. Okay. Other than that. So now about the control variable collection, actually, in my opinion, this is also fine. We can connect based on this, or we can connect using other rule. It says connect all the control with all the independence. I think this is the best rule, maybe. Okay. All right. So this is fine. Okay. Now I run. Let me see what I get. Good or bad. Again, it becomes no, still saturated. It is still saturated. Okay, some issue is there. So modification indices, what it suggests? There is no indices, but I think I should connect this with this. Okay, connected here and here. I'll connect this, and I'll connect this. So all dependent variable, and this is extra. Let me run. Yeah, this is better, isn't it? This is much better. Yeah. Nothing. Yeah, this is better. I think this one, this model. Oh, this was the imputed model. Now we understood what imputed model is, and this looks better. Always take, if you take a screenshot, you take with the standardized estimates. Okay. So we ran the structural modeling using the imputed model. Okay. Now, so path analysis was done. Next topic is mediation. Do you have any questions here, guys? Any questions? No questions. Okay.
Participants, if you have any
No
questions,
questions.
please
So
ask. So I think we should move ahead.
always, yeah. So always it's good to have control variables in the structural model. Need not be only demographic variables. It must be backed by your literature. Like the previous studies, what kind of control variables they have used, you can use the similar control variables backed by the literature. Next topic is mediation. So that was path analysis or direct relationship testing. So now we are moving to the indirect relationship testing. So now what we are saying here, in this case, we are saying that, see, previously what we tested between X and Y. Okay. Or we tested like multiple X's there, like that we tested. Okay, like this is X6, X5, X4, X3. X2, say X1, okay, and all connecting to Y like this, okay, like this, like this. This is what we tested earlier, okay. So Y is our dependent variable, X's are our independent variables, and this is what we tested, like a regression. We did that just now. Now these are all direct relationships. These arrows are directly connecting from independent variables to the dependent variables. Now we are saying that we want to know if there is any mediator in the middle. Is there any middleman in that relationship? Any mediator is there. So if that kind of testing we conduct, we call it mediation, or we call it indirect effect test. Okay. So if you look at this example, curiosity is our independent variable, learning is our dependent variable, and discovery is our mediating variable. Okay. So what we want to know here, curiosity leads to learning. This is there. Whether the discovery mediates the positive relationship between curiosity and learning or not. That test we'll be doing using the mediation. And basically it's how it works. This is like if I call this line A and if I call this line B, let's call this C. Okay, so mediation is nothing but the multiplication of A and B line, whatever the value they have. Okay, if the multiplication becomes significant, then we have mediation. If it is not significant, we do not have mediation. Okay, also sometimes people say full mediation, partial mediation, but literature doesn't give much importance to that. Like full mediation means like once you run this and this line becomes insignificant. Okay, this becomes significant, but the C, it will get becomes CI, this will become insignificant or non-significant. Excuse me, non-significant. Then we call it full mediation. Okay, but if the C also becomes significant and this is also significant, then we call it partial mediation. Okay, and if this is not significant in any case, no mediation. Okay, so we'll be running now mediation. Okay, now we'll be running the mediation model. There are multiple ways we can run the mediation. I'm going to teach you the best method to run the mediation. You're supposed to use the one more point. You're supposed to use the bootstrap confidence interval. One more point. Mediation we can test using the p-value approach. Like p-value, the rate is less than 0.05. Usually we follow this threshold. We say there is a mediation taking place. Another thing is called bootstrap confidence interval. Okay. Yeah, I'm just writing. In that case, both upper, lower bound or lower limit or lower bound, this is lower, and upper, both sides actually, both have to be positive or both negative, or then it is significant. If one of them is positive, another one is negative, not significant. Okay, both have to be positive because it must not cross span 0. You know, number theory, integers. Okay, so if it is 0 and this is like 1, 2, 3 positive, and here it is like -1, -2, and say -3. So that means what we are telling, it should not cross 0. It should not span 0. If both the scores lies this side or that side, it is significant. If it spans 0, then it is not significant for mediation testing. Okay. So now we'll do that. Okay, we'll run the mediation testing in the same model. Okay. So we're going to use the estimate. We're going to use the estimate to test it. So how to use the estimates? Here, bottom left, in the bottom left, there is something called not estimating any user defined estimate. Please click this. Then you see select estimates. Okay. And then I have shared 3 estimates. So from there, you select my indirect effects Amos estimate VB. Let's select that one. Then only it will run, otherwise it will not run. Okay. After doing that, which mediation you want to know? Run. Suppose I want to run now this one. Okay. Single mediation. So play mediator role of useful between playful and infatuation. This is what I want to run now. Okay. So what I have to do for that? These 2 lines have to constrain with the capital letter A and B. Okay. So first letter A, because that way the software is designed. Okay, then only it will run. B. Okay. A into B I have done. Now I'm ready to run. Just go to analysis properties, go to output. Okay. Go to bootstrap, performing bootstrap. I'm going to perform 2000. Okay. You can perform 5000 also. Sometimes people also go 10,000. More the bootstrap, it will take more time to run it. So, and also from the output, you have to check this box, impute indirect, direct, and total effects. Okay, and from the bootstrap, you have to check this box and this box. Okay, then you close it. After closing, let's run it. So we ran or not, just a moment. Output. Okay, yeah, we ran. Go to view text output. Model fit would not change because we did not do anything. If you want, until unless you change the model, model present would not change. From here, you have to go to scalars. From scalars, you have to go something called user defined estimates. For the old SPSS people, it would be written like my indirect effects. Okay, this is the value 0.0106. Now I want to see the confidence interval. Click bootstrap confidence. So 0.106 is the estimate, 0.068 is the lower limit, and 1.157 is the upper limit, and p value is less than 0.05. So it is significant. So this is significant. Okay, this result is significance. Here it is also good. Here it is also good. So we can call this particular one. Moment. Okay, it is significant here. So we can call it, there is a mediation between useful mediates the positive relationship between playful and info acquisition. Okay, like that we can do. Okay, suppose I want to do serial mediation. Okay, I want to use two mediators like this model. The previous model was very simple. Previous model was like this. Okay, X, M, and Y. This was previous model. Now I want to use, okay, serial mediator where the model would become something like that. So two mediators. Suppose I want to do two mediators. Okay. Just one, yeah. So if I want to test this, so I have given already A. So there are actually three lines. So this is like A, B, and C. Multiplication of these three will give me mediation. So another C, I'm going to click poly here. So A, B, C, and then I can get the serial mediation. Okay. So you have to change the estimates. If you want to use serial mediation, there is different estimates. Click here, select estimates, serial mediation. You have to use this one. Otherwise, not work. After that, you actually double click, give C regression weight, and then you go to text output. I think it is all good. Just run it. Okay. Go to view text. Model fit, nothing will change because we did not change anything in the model. One estimate, this is the estimates, and these are the values. Lower limit is also positive, upper limit also positive, and p value is less than 0.05. So this model is also significant. Okay, like that we can do serial mediation. Okay, guys, I'm going to take 3 minutes break. Okay, and when I come back, I'll do the moderation and I'll take your mediation related question.
Okay, sir.
All right, guys, I'm back. So, do you have any questions related to mediation?
Sir, I think everyone will be looking after the recording and then they will be practicing because they are
Okay,
just
okay,
beginners
okay.
in this
All
field.
right.
That's why.
Oh, okay. Now we'll go for the uh,
So there is one question in the chat box. Should I read it for you?
okay. No, I can read. I can read. No problem. Kiran, madam, your question is still not clear. Can you unmute yourself
Ma'am, you can
and
unmute
tell
yourself
me
in the
what you
chat.
actually are?
Or if you don't want to, just write it in a much better way,
Okay.
understandable way.
Yeah.
Model. Okay.
See, actually, one thing is that, ma'am, like that is based on basically it is based on your literature review, based on your literature. The literature backup has to be there. That is one way we decide whether we want to test mediation or moderation, okay, or simple relationships. That is based on literature. Another thing is that literature, there is something you want to challenge it. So that is based on your gut feeling or instinct, or they use another word, um, instinct, and there is something else in the research also they say. So based on that also they say intuition. Okay, so that way also you can test the model. Okay, now I'm talking about the moderation. Okay, talking about moderation, there are two types of moderation. The first one is the interaction moderation. So what happens here? So mediation was about the indirect effect. Moderation is about the joint effect. Moderation is about the joint effect, interaction moderation. So suppose in this particular example, it's very clear, obvious. We're testing actually whether the diet, you look at the bottom one, diet influences weight loss, because I use some kind of diet, paleo or some diet, and I start losing weight, all protein based diet. So that is one factor. If I'm doing dieting and at the same time if I'm exercising, whether the both effects will help me losing more weight, or nothing is happening, I'm losing the same weight, or I stop losing. Okay, so these things may happen. So it's called like interaction effect. So bringing one variable, mixing them together, and then if you run it, that mix, this joint effect, whether either it strengthens the relationship or weakens the relationship, or it changes the direction of the relationships. Positive may become negative, or negative may become positive. Okay, you may start gaining weight. I'm just saying, kidding. Huh? That is also possible. Okay, so until you test it, you would not know. This is very much clear. We know this, but sometimes we don't know. Correct. All right. So how moderator works, like here. So x, if your x is the independent variable, y is dependent variable, and let's say w is the moderator. So w, this line also you have to connect. Then you have to take x w. Okay. Z, why I'm writing z, I'll tell you. This line. Okay. So if this line becomes significant, we have a moderator. These two lines also have to enter, but we'll not be looking at their values, but we'll be looking the values here. Z means how do you multiply? Before you multiply them, you have to standardize it. So that means like it becomes ZW. You standardize X also. Only these two you have to standardize it, and then you multiply. Why do you do it? Because a moderating effect is a very small effect. If you do not standardize it, you probably would miss the moderating effect. Okay, I'll show you how it is done. Okay, this is an example of interaction effect. So I'm going to run the interaction model first now. So that interaction model, I'm not going to use this data because I think this data doesn't have this kind of like models. Okay, so for interaction exclusively, I have another data set. It's called interaction data set. Interaction data set. Is open interaction data set. Okay, and I'm going to open the same data set in the AMOS. Okay, same data set I'm going to open in the Amos. So yeah, so open your Amos, take the interaction data set, write new here, go here, data files. This time I'm going to import the SPSS data file. SPSS data file. Why I'm not able to see, I have to change this to all or Amos. Okay, I'm going to change this to Amos is AMW file. No, I want to take it from SPSS to .sav file. Okay, .sav, and I'm going to take interaction. Where is that? Interaction. Yeah, data set, this one. Click open. Okay. Bring this. Or also at the same time, you have to open a model. I have already created one model, a mass model. In that model, I'm going to bring this data. So interaction anxiety or interaction enjoy, interaction experience. Okay, let's pick out interaction enjoy. Please open this one. There you're going to bring this data. Please open the interaction enjoy model, a mass model, AMW model. Okay, yeah, it looks quite huge. Do not worry about this shape. Now you bring this data here. Okay. Otherwise, I would have to create the model. Okay, so interaction data set. Click OK. Click OK. Okay. So we got the data. Okay, this is our model looks like. So which one is which one? I'll explain you before I run it. So this is our Z. This is our moderating variable actually. This is our independent variable, and I'm testing at decision quality or info acquisition. I'm about to see. I'm testing in one of these. Okay, because both. Yeah, I'm not testing in info acquisition. I'm testing at. Yeah, this is what I'm testing. Yeah, this is my dependent variable. Okay, so it goes here, and it goes here. Okay, this is nothing. This is the multiplication of these two variables. So it's the Z value. Okay, so let me run it first, and then again I'll do the standardization, and again I'll bring this model to you. There. Okay, so let me run the model what it is. So you're just supposed to get this data, interaction data set on this particular model, interaction enjoy model, and you just go to analysis properties. Just see a couple of the boxes are opened, checked. Yes, these are checked. You need not be doing bootstrap for this case. Just and open the SRMR, this particular box, and run it. Okay, so we ran it. These values are good. Actually, it is less than 0.08. Go to view text output. Bigger. Go to model fit. Model fit is great. There is no issue with the model fit. Okay. And you have to look at here. The result is here, this particular line. So this is significant because why it is significant? The p-value is less than 0.005. Okay. Other places would be terrible. So it is significant because p-value is less than 0.05. How did I write? P-value less than 0.05. Okay, got mixed. Okay, so there is a moderating effect. There is a moderating effect. Okay, this particular line. Clear? Questions on moderation? Okay, yeah. How did I standardize it? That's the important questions. How do I multiply it? So I used in playful and info acquisition. So this is my original playful and original enjoy. Playful and enjoy, these two. So I have to standardize these two before I multiply them. How to standardize these two? Go to analyze, Go to descriptive statistics, go to descriptives, then you take playful and enjoy. Enjoy, guys. Yeah, this one. Just to take it. Standardize means this box you see, this you have to check. Select this box. Then only you'll be able to do so. Playful and enjoy. Click OK. Once you click OK, you would see two z square variables created in the species data set. Just scroll down. See, I have created these two variables. All right. I've created. So what I'm going to do now, I'm going to multiply these two. Okay, one is playful, another is enjoy. Go to transform, compute variable. And since I'm going to multiply, I'm going to create a new variable. So it's called like in playful enjoy. Okay. Playful enjoy, and you're going to multiply these two last two. Okay. What you got is multiplied by this. Click OK. Now you'll be able to see the see another variable appearing. Okay. So this is nothing but the multiplication of these standardized scores. So suppose if I want to use this data, so I have to save this data first. Without saving, I cannot relink. Now relink with your Amos data set. What data set I was using? Exact. Run. Yeah. All model fields are good. So you see, get the exactly same results. I think. Yeah. These are our results. Okay. All right. So there's the there is what? There is a um, playful and so enjoy moderates the relationship between playful and decision quality. What it means. All right. Now I'll move on to multi-group moderating analysis, multi-group. Okay. So sometimes we actually you want to display, like suppose you want to display these figures, you want to display in the charts like moderating. If it is significant, then only you display. Since this is significant, so you can also, that is stats tools wiki, stats tools package I've given you. In there we can also create some diagram or charts we can create for moderating effect. Validity master you computed, no? So two-way interactions. This here you have to supposed to create the charts diagram or the moderating effect diagram. So what are the variables names? Listen, quality, enjoy, playful. It is playful. Moderating is enjoy. And this is listen, quality. Okay, so how to enter this course? So enjoy to decision quality. I can put this score or that score. All right, enjoy to decision quality is 0.027. 0.027. Okay. Enjoy is a moderator. I'm sorry. This is not the correct score. It should be 0.027. Yeah. 0.027. Okay. Here, independent to dependent variable. What is the score? Playful to decision quality -0.056. huh, point, point 0.56, and finally, what is the interaction line effect? This was 0.028. By default, constant is 3. Do not do anything here. So what do you get? Enjoy dampens the negative relationship between playful and this is a product. So there is actually moderating, but negatively moderate. Negatively moderate. Okay. This way we can draw. Means this, if this line went up, then positively, otherwise it's just negatively moderate. Just okay. This is positive, negative moderated. So this way we can draw, but only draw for the significant one. Non-significant need not be drawing this. So interaction effect is done. Now we're going to do the multi-group effect. Any questions you have for from here? Questions? Multi-group. I have given a data set. It's called multi-group data set. This data set I have to import in the Amos file. So how to create group? Group number 1 you see here, left side. Here you write. So before you go, I'll just a little bit explain you what we are testing here. Let me close this. Let me open this. Yes, it opened. Now, if you look at here, I'm going to test only the destruction. Okay, so basically in this, what is the multi-group? Let me explain a little bit. Multi-group moderator. Yeah, this is like effect, no effect. Okay, this is also negatively and inversely. Okay. Multi-group moderation is basically you split the data set. So it is like group A minus group B. If this mean difference becomes significant, then we can tell there is a significant difference between these two, and this particular group moderates where one thing is for this group is this and another thing is for that group is that. Okay, like that. Okay, we actually give the hypothesis like that. Okay, so we can change this. So we have to split the group. Okay, like here, age moderate the relationship between exercise and weight loss, such that for age less than 40, the positive effect is stronger than for age greater than 40. Okay, that was a little complicated. If you look at the first hypothesis, that is quite easier. The relationship between X and Y is stronger for group A, or stronger for male or for female, like that. Okay, this example also I have given you. Okay, this data already been shared with you. Okay, so multi-group moderation, let's do that. Let's split the data set. Let's split the data set. So you have to create two groups. We have two groups here, like low distractions and high distractions. So we are testing whether the low distraction, I'm going to open that different model now. So low distraction leads to the learning. Okay, there's a learning model here somewhere. Once again, this is called, let's open this one, multi-group distractions model, already created for you. And I'm going to also run the same model, multi-group distractions. Once you open, you can see this model. Okay, so there are like actually two independent variables, curiosity and learning mindsets leads to learning. I can test in any one of these. I want to test on this learning mindset. Okay, I want to see if the distraction is low, the learning is taking place more, or if the distraction is high, learning is getting more. Yeah, learning is, you're getting more learning. Okay, so we have to create two groups here: high distraction and low distractions. So just click group number one here, and you can name a group. I'm just going to call it low and high, nothing else. Again, you create new, click new, close it. Okay, low, high, close. I think I already got the data. You have to get the distraction data set for each group. Low group. Okay, first low group. Go there, data file. Take which data set we are using? Multi-group data set. Now, what is the grouping variable here? What is the grouping variable? Distraction. Yeah, this one. Okay. Group value 0 and 1. Two categories are there. I'll just go with the 0 first one. High. Multi-group data set. Grouping variable. Same distraction. Group value. This time it is 2. Okay, we created two groups. I think something is 0. I did not get 0. What grouping variable? I think I missed distractions. Okay, yeah, that is what I missed. Again, group value that was 2 is 1. Okay. Oh, this should be 0. First one is low, must be 0. Okay. All right, two values 0. This must be 0. Okay, 0 1 like that. The first one, yeah, this way we have to do. I've given the data like that. You have to enter the data. Once you have entered the data, okay, now you low here, just double click this one, text parameter, all groups. Okay, no, not all groups. One of them you have to say A, another one of them you have to say B. Okay, so I'm going to say A. Oh no, I'm not testing curiosity. Sorry, I'm testing on the here. Here is that A. Here is that B. Already there. So A, oh, it came both places. I should have taken care of something which I did not take care. Okay, there's something called all groups. You have to deselect this. Okay. Now again, I'm going to insert A, close, go high. Yeah, it's coming like that. Why is that? Okay, high. Okay, I make it B. So low is A, high is B. A minus B is significant. We can get the result. See, low is A, high is B. Okay, go to analysis properties. Check. All good, good. Okay, got it. Okay, run. Go to text output. Model fit. The model fit becomes saturated. Ignore that. We're not interested here. Okay, we are looking for okay, the results are there, but we should have used the plugins. I did not use plugins, so I missed it. So I'm going to use the plugins because since I've said A and B, so I'm supposed to use the plugins. Okay, A is here, B is here, right? Supposed to use plugins. So go to not estimating any user defined estimate. The bottom left, double click here, select estimates. I have given something called my group difference. Yeah, this plugins you can use for moderating effect. Click here. Now I will be able to run it. Now, since I've used this thing, I'm supposed to get the bootstrap also. Then only I'll get the results. Otherwise, I may not get the results. Now we're back. Now go to estimates, go to scalars, go to user defined estimates or modern effects. So 0.444. Bootstraps are best. A minus B. Or you can look at here. I should have used the bootstrap also. You need to use bootstrap, otherwise you'll not get it. So again, I'm going to run it. Go to analysis properties. This one I missed. Bias corrected 95. I have to put correct. This one I missed only. Otherwise, this was not very direct. But bootstrap I given only 2000, but I did not get this one, so I did not get it. Now I'm going to run it again, and this time I'll definitely get the right value. Go here and go to estimates. Go to scalars, user defined estimates or old users, micro differences will be written here. Now go to bootstrap confidence. So we have a moderating effect. We have why I'm telling this. This is the estimate. This is the lower limit. Both are positive and p value is less than 0.05. So we can tell that there is a moderating effect in this model between here. Learning mindset destruction moderates the relationship between learning mindset and learning, where low distractions lead to more learning and high distractions lead to less learning. So if you look at these values here, see, high distraction means 0.08, only this much learning, but low distractions 0.52. There is a great difference, isn't it? So that is the way you can test the multi-group effects in the moderating effect here. Okay. Another method is there. If you want to test that method also you can use. What I'm going to do, I'm not going to use estimate. Okay. So I'm going to ignore. It's called do not estimate. I'm going to remove A and B both. Okay. So it's called actually chi-square difference test. So how it will be done? So first, we are going to use no constraint. Okay. So there is nothing, just run it. Okay. But this is quite vague, this test, but let's do it. Okay. So now 0.8 for both, you get the same value. Actually, yeah, it's different value. All right. High, low, we're not using. Okay, no problem. So just copy down your chi-square. So chi-square is 0. Degrees of freedom is also zeros here. Okay, I have shared something called chi-square test, something like that. Also, you can create is equal to chi-square distribution. That way also you can create. Let's open that sheet which I have shared. Okay, it's called it's Excel sheet, Excel file. It's something called chi-square calculation. Please open that one. So what is the original score? Chi-square is 0 and degrees of freedom is also 0. So enter enter similar fashions. Okay. So I've entered this is 0 and this is also 0. Now modified means constrained one. So what to be constrained? This line has to be constrained. So you can call it anything. Okay. You can call A, Bob, or you can call this. Okay, let's call it Bob. Okay. So Bob, high also, low also, high also, low also. Okay. Okay, I'm gonna call. Okay. Bob. It has to be safe, otherwise it will not run. High also safe, both is also safe. Okay. Now safe, both are safe. Now I'll run. Now it is constraint model. So what is my chi-square value? The chi-square is 12 and degrees of freedom is 8. You can also look at here. This is shortcut. But if you want to look at view text, you can also look at node for the model. Chi-square is 12.771. Degrees of freedom is 1. So it is 12.771 and degrees of freedom is also 1. All right. So what you get? It's significant, right? It is significant. It is like single tail test. Okay. If you want the double, you want the like two tail test, you just double the p value. Still, it is significant. Way less than 0.05. So this way also you can test the group difference. Okay. So there is a group difference between these two. Okay. and that is there. All right. So, uh, so distraction modulates the relationship between learning mindset and learning. But here, I think if I use this, I think it will not run. This is Bob, and if I call this Rob, this time it will not run, 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 run. No, it will run. It will give the same. It will run. Same. Okay, one second. So, first was check. Say Rob. This is called Bob. Now I want to see whether it runs or not. No, it doesn't run. It doesn't run, guys. So here it will give same. Why it doesn't run? Because the chi-square value is still 0. So we have to constrain the same thing, not the different thing. Means both have to be same. If either Bob, Rob, or you can call it A. Okay. A. For this also A. For this also A. Now it will run and you'll be able to get that. Okay. 12.8 or 12.771 and 8. So this is like moderation test. Okay. Similarly, yeah, this is moderation test. So with this, I conclude my session. I have covered all the topics. So if you have questions, go ahead. I want to take some screenshots. Please share your screen. Just a moment.
Yes, sir. Participants, if you have any question, you can ask sir directly over here. So there is a chat. There is a question in the chat.
Okay, just give me a just give me a minute. I'll just take
Yes,
one or
sir.
two screenshots and then I'll respond to those questions. Just 30 seconds. All right, what questions you have? As I am doing first time was, I am unable to understand what are the important results that look into the CFA and path analysis to interpret the margin. I detail in detail. I have explained the CFA yesterday. Okay, and path analysis also goes same fashion. Okay, so suppose you want to say the hypothesis testing results, you have to look at like p-value less than 0.05. If the p-value is less than 0.05, that hypothesis is significant. Okay, if the p-value is greater than 0.05, not significant, so we cannot reject null hypothesis. Okay, read some literature papers, how they have interpreted, how we, how they have written. Similar way you have to write. Okay, clear, madam? Dr. Pushpakiran Singh.
Ma'am, are you satisfied with the answer?
Yes, sir. Yes, sir. Actually, so many things are coming out after applying the MOs, and something is important for the result, and some analysis is not important for the result. So I'm very much confused about that.
Oh, that's like yesterday at detail I said, like suppose I ran CFA. So CFA, that model fit explained that same model fit applies to the SEM also. Four
Right.
things you are required: that chi-square and degrees of freedom ratio, CFI, RMSEA, and SRM are values. These model fit indices required. Okay. Regarding the regression line, that regression line, no, you see the regression line, those values are required. So I have made the tables for you. Okay. So like those things are only important. Watch the videos carefully. And suppose even if you need further understanding, you have to read empirical paper, how they have explained the interpretations, what kind of things are there in the table. That will also help you in getting clarity. Okay, if you are doing first time workshop, you may not understand everything. You have to attend like few more workshops, then you'll get some clarity and flow. And also you have to practice more, so you learn it. In this way, you learn it. Okay. So these were the actually important analysis. Okay, EFA, CFA, path, mediation, moderations. Okay, rest, how to interpret, how to write, you have to seek the help of the research papers. Okay, Emerald research papers, Springer Nature research paper, Elsevier research paper, good journals, good papers. Use Google Scholar or some other sites to get the good research papers. If your university subscribe to ProQuest or some databases, get the good research papers. Read several research papers, then it will give you a full-fledged understanding. All right, so if there is no questions, we can call it off, ma'am.
Yes, sir, we can. If you have any more questions, participants, do we have any more questions? And
Sir,
query. Yes, ma'am.
when
Yeah.
doing the CFA and we are taking the resource of literature, then also we need to validate the constructs.
What is again your CFA is a construct validity. Like
Yes.
EFA, you're talking about that whether EFA I have to do or not.
No, for CFA, we have it is mandatory to calculate the
CFA is
convergent
mandatory.
and the discriminant validity.
Yes. CFA
Okay,
is mandatory. Calculation of convergent discriminant validity is mandatory. EFA is not mandatory. Exploratory is not mandatory. Okay.
right. Okay. Thank you, sir.
You're
And for
welcome.
normality, we have to check the normality also.
Skewness and kurtosis use the 3 threshold value. First day of workshop I explained. Less than
Yes.
3,
No,
if it
I am
is
just
less than
asking.
3, it means your date.
It's mandatory to check the normality also because we are going for the structural equation model. So it's necessary to
Yeah,
check
see,
the
structural is
normality also.
it is necessary in that sense. Structural equation moderation assumes that your data is normal. Okay,
Yes, it's
so
normal.
normality, if your data is large, it is assumed that you have a normality. You have fulfilled normality. Okay, even if you don't test the normality.
Okay.
Okay, that is called central limit theorem. There is a concept called central limit theorem in the statistics. That
Right.
theorem assumes if your data is significantly large, it means you have a normal data. Okay.
Right.
Now,
So is
for
there
your
any thresh?
safety, better
Yes.
to have
Yes, sir.
normality testing done. Somebody can ask you that question. See, suppose if I am
Right.
reviewing your paper, I'm not going to ask it if your data is large. Okay, because I know the answer. But somebody
Right.
maybe no, you should do that also. Then you're supposed to do it.
Okay, right. So there is
Also,
any
one thing, please remember: if you
yes,
are doing a if you're
yes, sir.
doing a PhD, suppose if you, I don't know whether you're a PhD student or
Yes, sir.
already
Yes, sir.
completed
I'm PhD
PhD. If you're
scholar.
writing a, yeah, then you must do normality because PhD thesis means you can do a lot of tests, you can include a lot of tests. Paper writing, sometimes they don't have that kind of space, so they say just ignore that table, you don't need it. Okay,
Right.
so PhD, go with the normality testing.
Right, sir. Right, sir. So there is any threshold for the large sample size? Like
That is
if I
like
have
usually
300
300.
or the 400, what is the minimum limit to
Yeah.
estimate that it is a
Like
large
that saying, no.
size?
See, large, there is nothing called minimum. Large, based on some, some based on some guesswork idea, we make it, or some formula is also there. So
Right.
small is very clear. Some book says 30, 40,
30
50,
is.
60.
Hmm.
Okay, small.
Right.
61 does not become large. Got my
Right.
point? Okay. So so some people say, some books say 200, 300, 400, 500 samples are considered large. Okay. Another way to look at here, the number of variables you have, like number of items. Okay.
Right.
Suppose you have 50 items. Okay. 50
Hmm.
statements. 50 into 5. So 250 is the minimum sample size requirement. So that 250 is the large. Okay. 200, if you ask me, based on my experience, any sample greater than 200, equal to or greater than 200 is large, regardless
Okay.
of the variables number. Okay. So
Right.
300, 400 is really good sample, large sample. 200 is little bit like lower side, still lower end. But if you have like 300, and some book says 384 is a golden number, 384, because there is a formula of Pokhran. You use that formula, it will ask you only 384 to collect,
Yes.
380
Yes.
or 384. Okay.
Yes. Yes.
So that is, so somewhere that is where 400 means really good sample. Nobody can tell you that 400 is small sample size, regardless of number of your statements, isn't it? So
Right.
go with your guts. Okay. Instincts.
Okay, sir. Thank you. Thank you, sir.
Okay.
So do we have more questions? I think we don't have any more questions, sir. So certificates will be sent
Yeah.
to you in 2 days, and the recordings will be sent as usually by evening, like by late night. And I'll be sending the certificates on your mail only. Kindly do check your mail after 2 days. Like it will take 2 days, and then you can check it out on your mail. And thank you so much, sir. Thank you for sparing your time, your 3 valuable days. I would like to call you again for some other data sets for some other softwares on our platform. Thank you for being there. And thank you every participants for like showing interest in learning. Thank you. Thank you, everyone. Thank you so much, sir.
Okay. Thank you. Okay. Thank you. Okay. Thank you. Bye.
And thanks a lot, everyone.
Thank you.
Thank you, ma'am.